G'day champions, we've got this little Walter 22 watt head here. We're going to take it apart. I've already figured out what's wrong with it in a previous live stream. I fixed the initial fault, which I'll show you from some edited footage from that live stream, and then we'll get into the nitty gritty of it, see what we can learn from it, have a look at the circuit which I've traced out, have a look at the construction, and see if there's any other areas for improvement that we can offer the customer before getting it together and giving it a quick sound test. I'm not going to go crazy with modifying the circuit. I'm just more reliability mods and just making sure the output valves are operating in the correct sort of region that they should be for a maximum lifespan. Now, every time there's this so-called boutique amplifier that comes on the channel, it can be a little bit controversial to some people. I don't understand why. I'm just telling you what's in front of my face. I'm allowed to have an opinion, so are you. It doesn't mean that you need to attack someone because it's a different opinion to yours. I'm just showing you what's in front of my face. If you've got a problem with that, well, that's a skill issue. Right, so at first glance, they've chosen their joint positions well. It almost looks seamless from the front. You can see that they've positioned the joints at the side there and folded the whole thing over from the front, which gives it a seamless look from the front. I've gone with the Fender vintage style leather handles, which I'm not a huge fan of, but if you are going to use it on anything, just use it on a head, because they don't destroy themselves as quickly as a heavier combo. They've got what appears to be a laser cut chrome plated front logo, which is a classy touch. Got what appears to be switchcraft jacks on a silk screen front panel, chicken head knobs. You can't really read the writing with that position, but with the size of the faceplate, you sort of can't read it anyway, no matter where you put the writing. Fender style pilot light, and power and standby. It's a pretty nice looking finish to it. It's got a shellac on there, but they haven't overdone it. It doesn't have the real shiny sheen to it, which means it ages a little bit more gracefully than when people lay a million coats on and it goes a bit plasticky looking. And we've got two screw chrome plated corner protectors on every corner, top and bottom. Just a quick look at the back. We've got the same old thing where they don't use the cup washers on the screws, so the screws sink themselves into the timber or ply or whatever it is. So you can use a little cup washer on there to stop that if you're building your own amp, or if you've got an amplifier that they haven't used it, you can just pull that screw out, put an appropriately sized cup washer in there, and you don't get that cutting of the tweed. We've got a 240 volt input, 1.5 amp fuse there for the mains, and speaker out and line out on the rear panel. So this is a piece of black anodized aluminium with laser etching for the writing there. It seems a little bit odd to have that for just the speaker and line out, and then nothing except that looks like the dymo labels. Maybe it's just because they changed that per region, which you'd have to, yeah. So looking at the chassis from the rear, it looks suspiciously like those Hammond boxes that you buy pre-made, the spot welded on the corners. Only looks like 1.2mm thick aluminium, which means there's probably going to be some deformation around the transformer mounting points unless there's some reinforcing plates on the inside or something like that. 1.2mm is fine, but I'll be using steel powder coated rather than aluminium. It's a bit stiffer. So we'll just remove this rear panel with difficulty around the camera. Got stainless steel screws, which is always a nice touch, and that looks to be birch ply. Alright, we've got some massive oversized washers here, which is a nice touch. Oh, and the screws just pass all the way through. And we've got some just nuts and lock washers and washers on the other side rather than any threaded inserts that are riveted to the chassis. But yeah, that's like, it's a little bit funny that they go with no washer on the rear section and then a massive washer for the chassis. I understand there's more weight on the chassis, but yeah, that's a huge washer. They're good. I've got to figure out where to get some of them. They'd be good for transformer mounting points on the inside of center chassis like this example. So we've got multiple rows of 50mm foil tape, nicely pressed to the bottom surface, no real rips to speak of, which is good. It's been removed with care in the previous maintenance cycles. Lots of dirt on the cabinet on the inside around it. You can see the outline of the footprint of the chassis there, so I'll clean all that up as best I can. Being that it's a sealed Tweed, we can get a little bit of moisture on there, but it's broken through in some places. I don't want to go soaking and stuff, but just to brush off what we can, and then a just slightly damp rag to take off the remainder. You can see the colour of the shellac that they've used on the inside there. It looks to be shellac, and that's offered a tint to the Tweed. The Tweed's actually a pretty stark pale colour when you get it unfinished, so whenever you see a nice warm looking end like this, chances are it's had a few spray coats, which also helps lock the fibres in, which I'll show you when I finally get around to doing the last video of that, how to build your own champ cabinet. Sorry it's taken so long. I get excited about a project, I start it, and then I get busy and I can't justify the time spent on doing a fun little project when I've got a million jobs to get done. But looking at the inside there, that looks to be birch ply for the cabinet as well, probably 15mm plus about a millimetre for each layer, so about 17mm overall thickness. But you know what, that's inconsequential, so let's have a look at the circuit, and here's where I'll show you the footage from the live stream where I fixed the initial fault, and then we'll go from there. Oh, it's always good when you take a chassis out and it's already rattling. Look at the resistor flopping around. That's good. This 250 ohm cathode resistor flopping around because it wasn't secured in any way, shape or form. Okay, so what have they done? They've gone... Why are they going cathode? Oh no, they're not cathode to cathode. Alright, wait. Pin 1, which in some valves is a suppressor grid, they've got that connected to ground on both valves. Then they've got the two cathodes tied together via that black wire underneath. I can move that out of the way. And then they've got these two going from that terminal to that terminal. So they're spanning a pretty long distance and they've got really long leads. At least they know to keep the cap away from the resistor. So mounting that more securely would have been good, but we'll tackle that now. And maybe just rewire that in a better way. That would have destroyed this cap, because with that resistor gone, essentially open circuit, that cap would have seen way more than 25 volts, so we'll replace that as well. So there's our tag strip. Sort of twisted, and it's got a crack there. So what have we got? 5 terminals. We only need 3, but spaced. I'll see what I've got in my little box of tricks. So let's cut that back a bit and re-strip it. I think the jacket's melted to the wire a bit. Oh no, it's top coat wire. Sweet. That had heaps of excessive length, so we can afford to lose that burnt shit off that. This is that silly cloth covered crap. Just check for any nicks where I've stripped it. No, we're all good. Alright, so you can see all the dirt and dust on the chassis there. We're going to have to clean all that off before we handle it too much, because it's just gross. Starting from the rectifier, I've got a Sovtech 5Y3 GT, 2 6V6S's from JJ's. They can get microphonic in a combo, but in a head they're generally fine. And we've got a metal can 6 SC7, so the plot thickens. Now the plot's really thick. We've got a 6 SC7 to 12A underscore Z. I think that means 12A underscore 7 adapter, and we've got a 12A T7 in there. We've got what appear to be belt and sockets in there. Are they suspension mounted? They're a little bit off the chassis, but already you can see the chassis bending and twisting like a trampoline when there's any weight put on it, and the transformer's already tilted inwards a bit. So that's not great. Just to show you what I mean, see the whole top's flexing because the chassis is so thin, and everything's tilting inwards because of the weight of this, well, both the transformers. So yeah, I dare say that's a stock Hammond box, but let's check the dimensions and find out. Alright, depth we're looking at 202 millimeters. What's that? What's that in Frankenstein? 8 inches, bang on. That's looking like a Hammond if it's standard 2 inches. And the length, bang on 1 foot. So 304 point whatever the fuck. you know, 1 foot by 8 inch. And we're looking at 50mm high, so 2 inches high. Thickness wise, we're looking at exactly 1mm. Alright, champion, so here's the Hammond website. You can see the aluminium boxes, they have the same sort of look. And here's our man. We've got 1mm thick, 305 by 203 if we change that over to inch standard. 50 thou, sorry, by 12 inch by 8 inch by 2 inch high. And here's the data sheet. So that's our box. It's a Hammond off the shelfer. And as you can see here from Hawk USA, they retail for $27.20 US. Of course, the savings are offset by the fact you've got to manually drill everything. Generally, if you're in production, it would make sense to get everything laser cut. So everything's laid out for you already. And all you have to do is unwrap the thing and start mounting hardware. That's what I'd do anyway. Alright, champions, here's the schematic which I traced out. I actually put this one directly into KiCad while the amp was on the bench in front of me, because my mate Carlo from Ignite Amps was giving me shit for actually writing stuff on paper with like pencil and paper before transcribing it to KiCad. He's like, what are you doing? Just put it straight in. I said, alright, I'll give it a try, and actually it was way easier. So thanks, Carlo, if you're watching. You probably got better things to do than watch my videos, but anyway. So essentially, this circuit may look pretty familiar. You've got these two inputs here, which are a little bit different to the one I'm thinking of, but you got two essentially grid leak triodes here, 4.7 meg grid leaks, 270k plate loads, 47 nano coupling caps, usual 1 meg volumes, 2.7k there, 25 microfarad there, more 270k plate loads there. And you've got a paraphase phase inverter here, and cathode biased output stage. So pretty run-of-the-mill early Fender stuff. And if we have a look at the 5C3, it's got two 6SC7s. So I've got a feeling that 12AT7 in the adapter is because they couldn't get their hands on another 6SC7, so they made a adapter and replaced, maybe they had a failed 6SC7 and replaced it with a 12AT7. I can't remember if that is compatible or not. Pinout wise, I know it's not, obviously, because they're octal, but yeah, in terms of its characteristics, I'm not sure. I'd have to look into it. But you can see here, you just got some different value changes, primarily because these components don't adhere to the E6 standard. So the main difference is instead of 5 meg, you'll have 4.7 on the little Walter to suit currently available or easy to get values. Things like 250k, 270k is on the actual amp, so that's likely again fitting the E6 value series. And possibly simulating like a vintage amp where they're drifted a little bit high, that kind of thing. The other big difference tonality wise is instead of this 10k screen grid node dropper, they've got 100 ohm on the little Walter, so that would give a lot more clean sort of headroom. But essentially it's this architecture, the 5C3, with some value tweaks. And actually here I was mistaken. I thought the 5C3 had one directly coupled input pair and then one capacitively coupled, but they're actually both capacitively coupled on this one as well. And then that's got two 75k grid stoppers, which this unit does not. Alright, we've got a little bit of cap artwork there. Now we've got one of the wires here snapped off as well, so that was probably causing issues. And that is the feedback line, negative feedback. Now here's that resistor which I've mounted a lot lower, so its resonant frequency is a lot higher, so it's not going to wobble around until it fractures its leads as much. There's not really anywhere else I can mount this, but I've redone the capacitor down here, put a new V-shay in there, because when this lifted, the voltage across that cap would have gone through the roof, so I replaced that preemptively, just to avoid any future issues in case it was damaged. And we've mounted it again with the leads as short as possible. You don't want stuff shaking around, because that's when you get what we had when I discovered it in a live stream. So champions, let's follow it through. I'm looking at it while you're looking at it. We've got two coupling caps there. So we've got both input caps. None are directly coupled to, neither input's directly coupled to the first valve. We've got what look like half-watt carbon films throughout. They look like Royal Ohm brand, I think. They've all got this spaghetti tubing insulating. So it's just tag board construction, point to point. And we've got Sprague caps. We've got Musi caps. I don't know much about them, whatever. Just film caps to me. They appear to have come from the factory with a PTFE insulation jacket on the actual leads, which is nice. And we've got a cable tie there tying them together, but they're just floating around. There's no silicone underneath them. Actually, no, that's just hot melt glue. That just popped off. So they're just floating around. So that was glued to that wire, but that wire wasn't glued to anything. So all of this has got to be secured a bit better, because that's not great. I mean, you can say it's great because, you know, whatever, but that's what led to the actual failure in this amplifier, the whole reason it came in the first place. So, and up the front, again, you got stuff cable tied to other stuff, but not really secured to anything except each other. I'm not a fan of point-to-point in general. I mean, look at this wire. That's not really ideal lead dress, is it? Look how long it is. So a lot of this could be neatened up quite a bit. This here's a bit weird. So this cap connects to this eyelet over here on the valve socket. Then the wire comes across here and actually passes through an eyelet in the tag strip, which is a potential point to break through the insulation on that sharp metal edge, because they don't deburr those edges in the factory, and that's sharp enough to take a fillet off my little pointer. So it hasn't affected the cable yet, but that's not how you secure cables. That's not good at all, because that could bite through, and then you've got a short. In this case, to nothing, because they're not attached to anything. But yeah, in another case, that if that was a ground eyelet or whatever, that could be an issue. I've got alpha pots there, which are fine. Sometimes their tapers are more suitable than the Burns or CTS. I'm not a huge fan of the pot metal bushings they use on them. They're a little bit not the greatest quality metal. I prefer a brass if I can get it, but hey, opinions are like arseholes. Blah blah blah. And you can see down in there's no lock washers on the jack either, so the dedicated grounding through that jack body isn't ideal. It's raw aluminium, so it's probably fine at the moment, but I'd like to see some lock washers on there. And lock washers mean you don't have to tighten the hell out of it so much that you might crack the front fascia either. And likewise for the pots, a bit hard to see down in there, but they've only gone with a flat washer in the inside. The same for the switches, no lock washers there. They're a bit of a difficult one to get a right size for, however, but there is one for the pilot light. Alright, we've got 47 ohm, just carbon film heater balancers. They do the job. I tend to go with 100, and I use fusible resistors, so if anything does fail, it's typically only an issue in amplifiers that have a cathode follower, where you might get a heater to cathode short from the large differential there, unless you elevate the cathodes like Friedman and many others do, which is a good idea. So working our way across the front, here's the rectifier valve. I would like to see some backup diodes in there to make life a bit easier on the rectifier valve. So it's only got half the voltage drop across it, but also if it ever does fail, the diodes kick in and you don't deliver AC to the caps, which could permanently damage them. Alright, let's see what's going on with the mains. We've got probably not mains rated cable, although that is the good cloth stuff with the, well, it's thick as hell, but that is the cloth stuff that's actually got the proper insulator inside it rather than just the purely cloth material. So we've got across there, across here to the power switch. That is the live. Okay, yep, good. So that's switched. I'd prefer to see a fuse before that though, in case that switch ever melts closed. There's nothing you can do to stop it conducting. It comes back from the switch underneath this bunch, up over here to the fuse ring, which is not good. I'll show you why shortly. And then that goes from the fuse ring to the tip via the fuse, and then to the winding of the transformer. Now that normally black would be active, They've gone the other way around, so neutral is, I'd have to double check, but as far as I know, I don't know if this particular transformer's got weird wiring, but you'd assume it would adhere to the states, black being active, white being neutral, whereas this is the other way around. So we've got the meter on continuity here, and then we've got the positive lead here just attached to the, well, where the mains input to this fuse holder is when the switch is turned on. And we remove the fuse. Now let's just put the meter on the other end of the fuse, and that's where your finger is when you're inserting the fuse. We've got continuity there, so I would be exposed to 240 volts right there if that fuse was okay. Now not only that, but literally just inside here, not even 2 millimeters inside, that's where the mains is, so even your finger can reach that. Not great. Now if we had the mains input attached to the fuse tip, at no point can my finger touch mains. It's only when the fuse is all the way in. So that's why we attach the power input to the fuse tip and the output, be it the transformer or the power switch, to the fuse ring. It's an added safety feature there. Now people say, oh, what if you got to reach in to grab the fuse, which is fair enough, but that's why these things have a spring retainer which holds the fuse captive in the end. So you put it in, tighten it, undo it, and the fuse comes out with it. To ignore that and then have that dangerous thing the other way around, well, if you had to reach in and get the fuse, guess what? You're touching it anyway. So yeah, we always attach the power input to the fuse tip. So the other thing that would make this non-compliant is you've got ground connection there, and then you've got the wire for that ground connection snaking its way all the way across here and then to the mounting bolt for the rectifier valve, which is not an eye-lock. So I think there's regulations with how far away from the mains input. Generally you want a dedicated bolt which has got no other ground for it except for the safety ground that connects it to the chassis, and you want it to be as close as possible, as practical, to the mains input jack. Well, that's interesting. We've got a is that a misfire? I don't know. Got some grooving from the socket and then a nut or a washer there sometime in the past. Now I don't know, maybe this output transformer has been replaced by a previous tech and the spacing was different, because there's not even a washer under those nuts. There's no locking mechanism whatsoever, no locking washer, no nylock nut, not even a flat washer. So we'll have to address that, because that's not great. Ideally what I'd like to do is get one of those monster washers from the chassis securing screws and just put one there and one there, and that would help stiffen up the chassis in that area. So really not a lot to this one. It's basically a classic Fender design, but in my opinion the 5E3 is a bit more of a classic for the reasons stated when we went across the schematic, and it's a little bit strange having the two inputs with the input capacitors there, as opposed to one that you'd use for harmonica or whatever, and then one for guitar. But hey, the customer loves this thing and it suits his needs perfectly, so we're going to do what we can to make these valves last longer, and we're going to make the mains safer as it should be, and as well as that, go through and secure stuff where we can, maybe improve the mounting hardware where the transformers are, that kind of thing. Anyway, champions, we know what we've got to do, so I'll hop, skip, jump to it, and see you on the next episode. We'll show you the finished product and what I did, and a few quick and dirty little sound samples, because that's the only way I know. So until then, shake it squeezy.